Hello, and welcome to the video on how to find a differential dy of a function that is a product of two functions. Now, we've differentiated a product of two functions before, but it's always good to have more examples so that we get better and better at the process. This also has factors that are a composition of functions, so we'll also use the chain rule. Now recall for the differential dy, my differential dy is equal to f prime of x dx. Now when I'm looking at the idea of this, what I need to do is just find the expression for f prime of x. I'll put it into its slot in the differential notation and have our differential. We have our function y is equal to e to the negative 4x cosine of 7x. So I have a product between those two functions, and that's why I need to use the product rule when differentiating. I also have a negative 4x in the exponent on e, and so I'll have to use the chain rule there. And I'm taking the cosine of 7x, so I'll have to use a chain rule in that spot as well. Well, recall from the derivative of a product, the dy dx derivative is equal to, well, we have the derivative of the first factor, e to the negative 4x, times keep the second factor the way it is, cosine of 7x, and then plus keep the first factor, e to the negative 4x, and multiply by the derivative of the second factor, cosine of 7x. So my dy dx is equal to, well, the derivative of e to the negative 4x, remember the derivative of e to a power is e to the, keep the power, but then multiply by the derivative of the power. The derivative of negative 4x is negative 4, so I'm going to multiply that in front of the expression. Now I'm going to have that times my cosine of 7x, and then plus e to the negative 4x, and this is going to be multiplied to the derivative of cosine of 7x. Remember, the derivative of cosine of an angle is negative sine the angle, so I keep that 7x in there, but then multiply by the derivative of 7x for the chain rule, which is multiply by 7. So my dy dx derivative is negative 4 e to the negative 4x cosine of 7x, and then when I multiply e to the negative 4x times negative sine 7x, that's negative e to the negative 4x sine 7x, but then also multiply by 7, I'll have a negative 7 e to the negative 4x sine of 7x. So this dy dx notation is just another way of also writing the derivative. So our dy dx notation is just also meaning my f prime of x. So this expression is what we'll put in for the f prime of x. My dy is equal to, it's more than one term, so we need to put it in parentheses, negative 4 e to the negative 4x cosine of 7x minus 7 e to the negative 4x sine of 7x, close the parentheses, and then dx. So that is our differential. Notice that when we did the derivative, we had dy dx is equal to our derivative. When we're doing the differential, it's dy is equal to the derivative and then times dx.